Muted.
Okay, there we go. Is that better?
Yes.
Okay, great. So I'll just say, and for those of you who haven't already, please type what state you're from or what nation if you're not from the U.S. It helps us keep track of where folks are joining in from. And would like to introduce you once again, Dr. Brian Bond. He's our presenter this evening for this Mountain Zoom. Dr. Bond is professor of biomaterials at Virginia Tech, also our extension specialist in Virginia Cooperative Extension. He's the associate director of the College of Natural Resources and Environment's Leadership Institute. And he will be talking this evening to us about solar dry kilns. He spoke with us a couple months ago about just basic business management for portable sawmills. And this evening we'll be talking about the design, construction, operation of solar dry kilns. He also has authored a publication on this topic, and as he's presenting, I will include a link to that in the chat box, so you'd be able to log in and find that publication. So Dr. Bond, thank you for joining us, and I'm going to turn it over to you.
Very good. Can you hear me okay?
Yes.
All right. Let me share my screen and we'll get started. Appreciate everybody's time this evening. Beautiful, beautiful day to dry lumber with a solar kiln here in Virginia. It was almost 70 degrees here in Blacksburg. Very nice considering the weather that we've had over the last couple of months, which were not very good for solar drying conditions. So I want to thank you for the opportunity to present tonight. We're going to talk about drying lumber with a solar kiln and go through some basics and talk about our solar design specifically, and then jump into some Q&A for those of you who've got some questions. As Phil said, I'm with the Virginia Cooperative Extension. I'm a professor in the Department of Sustainable Biomaterials. I've been here for almost, not quite 20 years. I was a professor at University of Tennessee 20 years ago before I came to Virginia Tech. And we've been doing solar drying for a long time. So hopefully get some information for you. So, why do you want to dry with the solar, why do you want to dry lumber anyway? And these are prices from, they're a little old. But the idea is there's a big difference between green prices and dry prices. And if you look at, the price on red oak there's over $350 a thousand between green lumber and between dry lumber. And obviously it's not going to cost you $350 a thousand to dry that lumber. So there's a significant opportunity for improved profit, or a greater percentage of profit than you would have with green lumber. That's one reason people want to get into dry lumber versus selling green lumber if you got a portable sawmill. But the other question you have to ask yourself is, if you're producing green lumber, is who uses rough green lumber? What is your market for rough green lumber? And it's pretty small relative to the market that you've got for dry planed wood. And I'm going to throw planed in there as, it's another value added step you don't have to do when you dry lumber. But think about what's in the picture here. You've got some pretty fancy woodwork on the top left. You've got the opportunity for doors and trim and wainscoting and new homes. And man, new homes are selling like hotcakes around here. And the wood prices are crazy. Tremendous opportunity there if you tie in with some custom home builders, but they don't want green wood. They're not in the drying business. They're in the home building business. So you got to dry the wood, right? Example on the top right, you got fancy molten, millwork and molding. On the bottom, you've got woodworkers and custom furniture folks. And then on the bottom left, the idea of cabinet makers. There's a lot of custom cabinet makers out there, and all these folks, they're in the business of making a finished product for a customer they don't want to dry wood. They don't want to be in that business. That's not where the money for them is. And so if you're a small woodworker, or I should say a small lumber business, the opportunity to expand your market and make more money with a dry kiln is significant. Being able to sell that dry lumber is going to give you a higher value added, increase your market share significantly. And so that's why most folks are looking at getting into the drying business from, if you've got a portable sawmill. So what is the goal of the drying process? So the goal of any drying process theoretically is to drive water out of wood at an acceptable rate of speed with maximum obtainable quality. And you can modify this objective however you want, right? You could speed it up. So not that long ago, there was a flooring plant in West Virginia was cranking out enough wood flooring per week. They were using over 1 million board feet a week. And so if you think about a drying operation like that, you're focused a little bit more on rate of speed and quality, but maybe not maximum obtainable quality. If you're a small sawmill outfit and you've got a limited customer base and you're dealing with higher grade material, you're probably going to focus a little more on the maximum obtainable quality, maybe not so much on the rate of speed. So we can play with these, with this overall objective all you want, and that may influence your decision on what kind of drying technology you want to use. So, one of the things you got to understand with the solar dry kiln right off the bat is it relies on the sun. And if the sun ain't shining, you're not doing much drying. And so it does have some significant limitations that we'll talk about, but it also has some advantages. So if you're living off the grid in the mountains somewhere or out in the plains and you don't have a connection to the grid, you could still solar dry your lumber and get an acceptable drying time and quality and a product that with the moisture content that you want. So before we get too far, we got to talk about moisture content. What is moisture content? So moisture content is defined typically in woodworking as the weight of water in wood relative to the dry weight of wood expressed as a percentage. Well, what does that mean? If you look at the equation here, basically, you take the original weight of a piece of wood and you put it in an oven, you dry it completely out, and then you weigh it again and you subtract that oven dry weight from the wet weight. Now, what all that does is it tells you the weight of water that was in that piece of wood. And then you divide by the oven dry weight, multiply by 100 for a percentage. Now, what this tells you is it's the ratio of the weight in water, of the weight of water in wood to the oven dry weight. And so you can have over 100% moisture content with this type of ratio. It's not telling you what percent of the weight is water. It's telling you what the water weight is relative to the oven dry weight. So if you take a species like balsa wood, very light, the opportunity to have a lot of water in there versus the wood mass you're going to have more water weight than you would wood weight. So a species like red oak, there's going to be less space in there for water to go. But the point is, I just want to make sure you understand that you can have over 100% moisture content. All moisture content is the ratio of the wet weight, the ratio of the weight of water to the oven dry weight of wood. And one of the reasons we use in woodworking and wood lumber or lumber production, the reason we use this is it tells us a lot about the mechanical and physical properties of wood at certain moisture contents, because we know that wood gets stronger as it dries. And we know that certain things happen based on a certain moisture content. So the fiber saturation point being around 30% is based on moisture content based on the oven dry weight. So that's why one of the main reasons we use oven dry weight rather than green weight as the basis. How do you get that? Well, you just take a piece of wood, a piece of wood, you weigh it, stick it in an oven that's above boiling point until the weight is completely, until it's completely dried out. You put that piece of wood on a scale and you weigh it again, and then you just subtract those two numbers and divide by the oven dry weight. So you see I've got about 0.9 kilograms over here. I got about 0.6 kilograms over here. I subtract those two for 0.3, divide by 0.6, multiply by 100, and I find out that that piece of wood was originally 50% moisture content. It's pretty simple to do, something you can do at home. You don't need any fancy equipment. Just need to make sure that that piece is dried out completely. And how do you do that? Well, you take that piece out, you weigh it, put it back in the oven for a couple hours, come back and weigh it again. And if it's losing weight, that means you still got some moisture to lose. You still got some drying time you got to do. If it's the same weight, hey, you're dry, you're oven dry, you're good to go. Go ahead and use that value in your calculation. Another way to measure moisture content is moisture meters. And if you're thinking about a solar kiln, you probably got at least some type of version of moisture meter. This is a pretty fancy Delmorst on the right. You don't need one quite that fancy. And then there's a dielectric Wagner meter on the left. The idea is that they relate an electrical principle to the moisture content that is in wood. What you have to be aware of is that these meters do have limitations. So they tend not to be very accurate above 30% moisture content, and they tend not to be very accurate below about 6% moisture content. And so you might say, well, if it's 6, why would I worry about that? Well, for machining purposes, if it's below 6, you want to know what it is. That doesn't glue well below 6, it doesn't machine well below 6. You've got problems there, as well as if it's too dry. And so using these in the drying process is a little dangerous if you're above fiber saturation point, but for figuring out if you're done and what the variability is when you're done, they're very good and useful tools. And we'll talk a little bit more about this one on the right with the pins in it when we talk about measuring your quality for the customer. So how do we dry wood? Well, you can just stick lumber out on sticks. The reason we put it on sticks is you want to get airflow on the top of the board and on the bottom of the board. And so we put lumber on sticks to get airflow on the top and bottom. You can stick that lumber out in a environment anywhere you want it to go, and it will begin to dry. So when you cut down oak, it's probably somewhere around 75%, 70% moisture content, green off the saw. You can stick it out on the air dry yard and you can dry it down probably here in Virginia to about 12 to 14%. I'm going to be a little high on that 12, probably go about 13, 14%. But if I leave it out there long enough, it will eventually get to around 12% moisture content or a little higher. Problem for me in Virginia is the relative humidity is usually too high for the moisture content of the lumber to get any lower. And so if I want to use that wood in an interior environment, I want that wood to be around 6 to 8% moisture content. I'm never going to get it there air drying here in Virginia. Now, if I live in Durango, Colorado, or Las Vegas, Nevada, the humidity is so low out there, wow, sometimes it's less than 20%. So that's right around a 5% moisture content in wood. Yeah, I could get it all the way down there just by air drying it if I was willing to wait long enough. But most places in North America, I've got to put some heat to it. I've got to get the relative humidity lower in my chamber to get that wood to 6 to 8% moisture content. So that's why we use a dry kiln usually. One, you can typically control the conditions. So if you look at the picture of the air dried lumber, what's it doing when it's raining out there? What happens when the relative humidity is too high, right? What happens when the wind blows and blows the rain in there? I can't control the conditions of the outside environment. In the dry kiln, I can absolutely control the temperature, the relative humidity, the amount of airflow, and I can keep the rain off the wood. And I can also raise the heat enough that it'll drop the relative humidity to give me a faster drying rate. And I can control that drying rate in a dry kiln if I know what I'm doing and I use the proper techniques. So that's why we typically use a dry kiln. Whoops, went one too far here. So a kiln of any kind, whether it's a solar kiln, a dehumidification kiln, a steam kiln, a direct fired kiln. Shoot, when I was in college, I used to buy wood from a guy that had a barn. He would air dry his lumber and then stick it in a barn with a wood stove and dry it out that way. You know, you can do it that way. If you wait long enough, it'll eventually reach equilibrium of the humidity in that environment, and you'll get to that moisture content, but you may have to wait a while. So a dry kiln really controls 3 factors, right? It's the temperature, relative humidity, and airflow. And I mentioned this, you know, most kilns, this is what you're talking about. Now you get into vacuum kilns, you start playing with pressure. And so you can modify these relationships a little bit. But for most of us, we're thinking about a conventional style of kiln. And so you're looking at temperature, relative humidity, and airflow in regards to what that kiln does. And that's exactly what we do in a solar kiln here. You know, you've got a collector that lets the sun in. We heat this airspace, so we've got some temperature. We got a fan in here to control airflow. And then my humidity actually drops. I can control my humidity by the amount of water coming out of the lumber. I have some vents on the back I can open if I want to drop it, or I can just use the raising of the temperature to drop that relative humidity. Phil, looks like we got one more in the waiting room. If you don't mind grabbing him, letting him in. What's that?
I'm not seeing another one in the waiting room. I'll monitor that though.
That's all right. My screen is probably behind. It just popped up. I don't know if you guys can see that or not. So there is a relationship between temperature, relative humidity, and what we call equilibrium moisture content. Equilibrium moisture content is basically if I leave a piece of wood in an environment at a constant temperature and constant relative humidity, it will eventually get to this moisture content. Okay, notice I said long enough. Now that could be a really long time, but eventually, if the conditions are stable, it'll eventually get there. And so let's just pick an example. If I'm air drying lumber and it's 70 degrees outside over here on the right, 70 degrees, I scroll over to what my relative humidity is on the top. So it's probably about 65% relative humidity, 70 degrees Fahrenheit, 65% relative humidity. I'll scroll over here. I can get a 12% moisture content if it stays out there long enough, okay? And you can use this chart to look at that relationship, but there is a relationship. And you can get a little more sophisticated and look at a psychrometric chart to figure out how much changing the temperature will change the relative humidity in a controlled environment. That's beyond what we want to do tonight, but just kind of understanding that there is a relationship between temperature, relative humidity, and EMC is very important if you're going to understand the drying process. So if I've got a higher temperature, right, I can get a nice low EMC. If you notice on this chart, as you raise in temperature, right, the EMCs just typically drop all the way across, right? When I got a lower temperature, 80% relative humidity, I got 16.5 EMC. When it's down here to 220, it's down around 9.9. So when you're drying lumber, it's important to be able to measure the temperature, be able to measure the moisture content, but also be able to measure the relative humidity. And these are just some tools that you can use to measure the relative humidity. This is a little wafer used in a commercial drying operation. This is pretty much the archaic, simplest way to do it, which is a wet bulb and a dry bulb. Basically, you have a thermometer here that measures the air temperature. You have a thermometer that has a wick on it. And so this wick is supposed to be wet. There's water in this chamber right here. It keeps this wick wet. And the rate of evaporation creates a cooling effect on this thermometer. So this thermometer should always be less than what this thermometer is. So this would be the dry bulb, and the term for this would be wet bulb. And the difference between these two, you can look up in a chart and see what the relative humidity is. Or you can get fancy and get a digital meter you can go from Walmart to Granger's to anywhere online and find a relative humidity sensor if you want to go that way. But it's very important if you're drying lumber to be able to measure relative humidity and temperature in the drying environment if you want to make any kind of changes to what you're doing in the process. So let's jump in and talk about the solar design specifically and focus in on the solar kiln. So temperature, we've already mentioned, is really important in a dry kiln. And so what influences the temperature in a dry kiln, a solar dry kiln? So you've got this glazing material. The sun enters that glazing material and gets basically, there's some reflection and absorption in here, and hopefully most of it gets transmitted through the glazing material. That's one reason why we use greenhouse rated tough text, is it has a very good transmission rate of letting those nice long wave radiation pass through the glazing material. We heat the air up in this area. And so the amount of sunlight that we have, the duration of the sun that we have, the angle of the sun in the sky, the angle of the solar collector all influence the temperature we're going to get inside the drying process. Does the temperature change in the drying process? Well, this is kind of interesting. In the solar kiln, the answer to that is yes. Why would that change during the drying process? Well, if you think about it, what is the heat used for in the dry kiln? Now, every day we got to heat up the structure a little bit, so there's some losses there. Every day we got to heat up the lumber, so there's some losses there. But it takes about 1,000 BTUs to evaporate a pound of water. So evaporation itself uses the heat energy. And so when the lumber is really green and there's a high moisture content, there's a lot of evaporation going on. And so it's going to use a lot of that heat, and it's naturally going to keep the temperatures in the solar kiln lower than it is towards the end of the drying process. So at the end of the drying process, there's going to be less water coming out of that lumber, which is going to use less energy, right? It's going to less BTUs because there's less water that has to be evaporated. And so the temperature of the solar kiln will actually be higher towards the end of the drying process. Well, that's good, because as the drying process continues, we want the temperature to be higher, because that's going to help drive diffusion. What the heck is that? That is moving the moisture from the center of a piece of wood to the surface so that it can be evaporated. After a while, through the thickness of a piece, you've got to get that moisture to move through the center of that piece to the surface to get it evaporated. Well, one way to do that is to increase the heat. And so just how the process works, you will see the heat increase, or I should say the temperature increase, as the drying process progresses naturally in the solar kiln, which is an advantage to us. Humidity is fairly similar, right? What influences relative humidity inside the dry kiln? Well, obviously the moisture content the lumber is, right? So if I air dry my lumber first, it's going to have a lower relative humidity when I put it in there. If it's dead green, it's going to be a really high relative humidity. I can open the vents. You can see the vents on the left here. I can open those up to try and drop the relative humidity from being high inside the kiln to being lower, hopefully on the outside of the kiln. One of the things that happens with the relative humidity in the drying process is, as the temperature is raised in the solar kiln, the relative humidity will drop naturally inside the solar kiln. And so the farther along we dry and the higher that temperature gets, the lower that relative humidity inside the solar kiln will be. And so ultimately, the relative humidity inside the solar kiln during the day will be much lower than it is outside, therefore allowing us to achieve a moisture content of the lumber lower inside the dry kiln than we would get if we were air drying that lumber. Okay, so the temperature is going to change throughout the drying process. The humidity is going to change throughout the drying process, just based on how it works. Airflow is pretty consistent in the solar kiln design. We're trying to move that warm air from this area through the lumber that's on sticks and rotating it around until the lumber is dried. Now, if I've got really, really green wood that I'm worried about staining, I might open these vents up, right, in the beginning stages of drying. Now, what is that going to do? That's going to help me evacuate lots of humidity, but it's also going to cause me to have a lower temperature, because that nice warm air, as it picks up the relative humidity or moisture off the lumber, it's going to be a little heavier, it's going to be a little cooler, and I'm going to exit it from the chamber and bring in more cool air into the chamber and have to heat it up with the sun. So I can open those vents, and it's going to allow humidity to drop, but it's not going to be as warm in there, right? Because I'm going to be letting that nice warm air out in order to bring in drier air that's going to be cooler from the outside environment. So opening those vents and leaving those vents open is going to cost me a little bit in regards to what the temperature is doing. But if I've got a really stain-prone wood, I'm going to do that just to get the humidity out of that chamber. So an example would be if I'm drying white pine, or if I'm drying hard maple or soft maple, I'm going to leave those vents open for probably the first week, maybe the first 2 weeks before I close them up. Okay, the basic design for that's the basics of any solar kiln design. And our design is got some things that are a little different from other designs. And it's basically designed to be really simple to build and really simple to operate, and to be built inexpensively as well, right? So our design is called a semi-greenhouse design, basically because it's not all solar collector. We decided to do that because where we live, It's not always super warm outside, and we want to hold that heat a little bit better. So we want some insulation in there. And so we've got some glazing in here. We've got good thermal insulation, and allows us better control of drying for our location here in North America. So where do you start? Let's start looking at the solar collector and the amount of heat that's needed to dry lumber, and we'll go from there. And so this is our current solar kiln design and size that we have out today. So you've got to start in solar design with some assumptions, right? And some of these are pretty rule of thumb versus super specific. You can get more specific data. It's out there for your location and exactly what you're going to get. But we can make these are fairly reasonable assumptions, right? From 1 square foot of collector, I should be able to get approximately 1,000 BTUs per day based on a 12-month average. Why based on a 12-month average? Well, obviously, it's going to differ between the summer, the winter, the fall, and the spring because of the angle of the sun. So if I average that out for a year, I can expect to get approximately 1,000 BTUs per day. Okay, it takes about 1,000 BTUs, then that's per square foot, by the way. It takes about 1,000 BTUs to evaporate 1 pound of water from wood. Now, there's little variances in here as well, but that's a pretty good, reasonable design average. And then if we look at the size of the amount of lumber we have in there, and we have, if we look at 4-quarter lumber, we got about 73.26 cubic feet of wood based on the current kiln design. And I can figure out how much water I need to lose if I look at the volume of wood in cubic feet, multiply it by the specific gravity of the wood, that's basic specific gravity, multiply it by the weight of water times the moisture content change that I want to have occur in the process. Okay, so if I take my 73.26 cubic feet of wood, multiply it by 0.56, which is the specific gravity of red oak, multiply it by the weight of water times 77%. Initially, I want to go down to about 7%. I find out that I got to remove about almost 1,800 pounds of water from 800 board feet of red oak to go from 77 to 7% moisture content. Right? That's a fair amount of water. You figure you can figure out how many gallons that is. It's 8.3 pounds per gallon. That's a lot of water to get out of the lumber. And so then I can turn around and say, well, how many BTUs do I need per day if I want to lose 2% in red oak? And where does that 2% come from? That's a very reasonable general average of how much moisture you can lose in red oak when it's green and not cause it to surface check and significantly end split. So I can do that same calculation except stick in there, I just want to lose 2% a day. And that's about 65 pounds of water per day to get a 2% moisture loss in 4-quarter red oak. Okay, and so then you can multiply that by 1,000 BTUs per pound. You get about 65,000 BTUs is what I need, assuming the sun is shining and assuming I get 100% efficiency out of the design. That's what I need, right? And I'm getting about 1,000 BTUs per square foot of collector. So then I can figure out my collector size and what I need square foot wise, and then I can come out with, if I've got 100% efficiency, wouldn't that be nice? I get about 96,000 BTUs per day, but I'm probably down around 50% efficient. So somewhere around 48,000 BTUs per day. And so I'm in that reasonable average where I want to be to lose 2% of moisture content per day based on the efficiency. Understanding, of course, there's going to be some differences between summer and winter. And so I'm within a safe range drying rate, for red oak with this design of 1 square foot of collector for every 10 board feet. And so that's kind of where that design came from. And you can see, obviously, if you're going to dry something like southern pine or all you're ever going to dry is yellow poplar, you can obviously increase the collector size because you can lose more than 2% per day. But that's what our design is based on, right? And so if all that was just too much for you and you're confused and you didn't follow the math, no worries. If you just follow that 10 board feet to 1 square foot of collector for drying oak and all species, you'll be just fine. It might take you a little longer on some of those species. You could dry faster, but basically that 10 to 1 board foot to collector ratios, that was kind of the logic behind why we chose that 10 to 1 board foot ratio. And so our design is based on that 10-to-1 ratio, with the assumption that at some point in your drying career, you're going to be drying red oak off the saw, and you're not going to want the surface check. Our objectives, our solar kiln objectives, were to be relatively inexpensive to construct and easy to construct. So it uses basic framing techniques, and to be simple to operate. Why is it simple to operate? Because we've designed it basically with that 10-to-1 board foot ratio. You're not going to exceed the temperature that you need in the drying process. So it kind of limits you in that, but it's also an advantage because you don't need to kind of monitor and control the process as long as you maintain that 10-to-1 board foot ratio. And a lot of these solar kilns have been built. They've been built all over the world, tropical countries and in northern regions and all over the place. And so it's a pretty successful design. Are there better designs out there? Sure, there's designs that'll give you more heat. There's designs that'll give you the opportunity to not have to move the lumber so much, but they're going to be more complex, more expensive to build, and a little bit more tricky to operate. So we feel like this is a pretty good design for someone who wants to get into it. So let's look at how you build the thing. How in the world do you build this thing? So we built ours quite a while ago. As you can tell by the color, people's hair is no longer that color. This is my grad student and one of our technicians who's since retired. That tells you how long this design's been around. We started out with a fair amount of plywood, which was our greatest expense by far, especially in today's market where plywood's probably 3 times what it was just a year ago. We put that on 4x4s to get it off the ground. Now the secret here is we also had a forklift at the time that would pick this thing up. So you'll notice we're building it indoors. That's because we were able to pick it up and take it outside. So we've got 4x4s on there to keep it off the ground, and that allows some air to move under the kiln to help keep moisture from going into the kiln. And heaven forbid, if any goes through the walls, it's going to carry it away instead of rotting those members. Then we just put in batt insulation, basically because it's just basic framing techniques. It's simple, it's cheap. You can use other insulation types if you want to. It's just what we did. I did use pressure treated wood on the bottom members just because I was concerned about moisture, ground contact. If moisture went through the walls, I was concerned about it on the bottom. So we did use pressure treated wood down here. After we put that insulation in, I put in a plastic sheet. I think it was, I don't remember the mil. I think it was about 6 mil, maybe 10 mil, to prevent any condensation that may occur in the dry kiln from going through that flooring member, through that plywood and saturating my insulation. That really was my basic concern, is I want to prevent that insulation from getting saturated if there's ever condensation that happens inside the dry kiln. So I put plastic down, then I put down the plywood. We nailed that into the floor. Typical standard framing techniques, straight out, if you look at the design in the publication, it's very straightforward. Straightforward framing techniques. Pretty simple to do. We use batt insulation on the walls and in the front as well. And then we came in and painted this with a concrete sealant, rubber sealant material. I used that because it was black and it would prevent moisture from passing through the membranes in the material. So I didn't want it going through my plywood and saturating those walls. And so I was using it as a moisture barrier as well as an absorbent. And you can see the fluted front here for holding the corrugated Tuftex. So that's my glazing material. Was just, ran out to Lowe's and picked up whatever they had. And that was basically a product called Tuftex. It was greenhouse rated materials. I highly recommend getting the greenhouse rated material because the plastic has a UV and protectant in there so that the plastic doesn't break down over time. You know how it is at Lowe's and Home Depot. Sometimes someone will put something back in the wrong rack. And you won't know it until you buy the material. And we had 2 pieces that were did not include the UV protectant, and they yellowed and broke within a few years, whereas the rest of this material has been around for almost 20 years and is holding up quite well. So that was our glazing material that we used. Any glaze, you can use recycled windows, you can use plastic. Just make sure that you've got a high transmission rate for those long radiation waves so that most of it gets pass through your glazing material rather than reflected. That's the big thing. One of the dangers of using windows from recycled windows from buildings is that some windows have a reflectant on it because you don't want the UV to pass through the window. In other words, if you're trying to keep a building cool that has a lot of windows, you might want to have those windows reflectant. Make sure that you don't have those if you're going to use recycled window panes. I mentioned that, you know, our glazing materials, Tough Tex. There's all kinds of things out there at this point. It works well for us. It was cheap and easy to get. Just make sure that you get the correct corrugated material to match it, which you'll see in a bit here. We didn't actually get the right material, but that gave us an advantage. So one question that always comes up is, should I have 1 layers or 2 layers of glazing to provide insulation in this area of the dry kiln? So this is obviously the area with the poorest insulation. In other words, a lot of heat could pass back through that collector rather than stay in the kiln. And I did not double insulate because I quite frankly ran out of money and time. Excuse me. If I was doing this for myself, I would double insulate. I would use that Tough Tex on the outside and then just get a 6 mil UV rated poly material, greenhouse rated poly material, and just put it up against the back and use furring strips and staple it in. And if you ever damage it, loading the kiln or unloading the kiln, it's very easy and cheap to replace, not near the cost of the Tough Tex material. Simple to do. The whole goal there is that you're providing, you know, if you put glazing on the top and the bottom, you're providing a pocket of air that provides insulation. And I'm not recommending that you do what they do here, which is blow air and collect your heat from that area, but basically use that area as insulation and barrier to prevent the heat from exiting if you want to, especially if you want to use this thing in the late fall and early spring. So the rear vents and loading and sample door, the very original solar kiln design done by Jane Wengert and Fred Lamb had all the loading done from a side door, which is, I don't know how they didn't bang their head all the time. So we just, when we redesigned a slightly smaller kiln, we put the doors in the back. I put a cable through the door to try and help it from sagging, and then tension that cable up with a turnbuckle. I did insulate the doors. One of the fellows that was working with us, helping us build the kiln, went out and bought these their vents for a crawl space, thinking that would be a big advantage. They're already there. You can open and close them. I do not recommend that. These particular vents are pretty much open when they're closed, and do not provide a very good blockage of air. So we had to fix that after a while. We do have too many vents in this particular design. I think you could easily narrow it down to 3 on the top and 3 on the bottom rather than 4 and 4. And we'll talk a little bit more about that later. Now you'll see lots of discussion online about don't use plastic fans. My plastic fans lasted about 6 to 8 years before I had to replace them. They're less than $20 a piece. When the college kids come back to campus, you can go to Lowe's, Home Depot, Walmart, and pick up these fans for nothing. And a good metal fan from Granger's was running around $100 a piece. And I said, you know what, I can replace these. And so they've been replaced once in about 20 years. The biggest problem is UV breaks down the plastic over time, and the heat, and they become brittle. But I consider that to be a pretty insignificant cost. So we've always used the plastic cheap fans that you would get, 3-speed fans. People will ask how those fans are held in the solar kiln. We just have a little 2x4 wall that are framing that goes from one wall to the other wall, and it's tied in on the wall. And it just holds those fans in there. They literally, we put electrical plugs in there so we can plug and unplug them, assuming that they would break at a faster rate than they did. And so that's just a little fan deck up there, and we drop our baffling, our plastic tarp baffle from that fan deck, and so it's tied into the stringers that are holding up the glazing material, and it's tied into the end walls there. a lot of times people ask about the difference between feet per minute and CFM. We use about 100 to 150 feet per minute. And you can calculate that by looking at the layers and the sticker thickness. You can figure out how many feet per minute you need. And for some reason in the drying arena, they always use feet per minute rather than cubic feet per minute. Other little things, so we had to come back in and fix our vents. So we created these wooden open and closing mechanisms later on, because we just thought we were losing too much heat with those vents for crawl spaces. You can see we added them in the back here. This is when it was first built. This is what it looks like now. Nice black interior. You don't need to paint the outside. We just did that because it matches the color of the building, and it would keep that plywood, which was our highest cost, keep it around a lot longer. We had to put a roof cap on there, keep rain from getting in and causing rot issues. That interior was Ames liquid rubber block and wall for concrete block. It works pretty good. It provided both the vapor barrier that I wanted, and it provided the black that I wanted for the solar absorbent of the solar energy. You could also, old designs, you could paint it with a aluminum based paint, and that doesn't mean aluminum color. That means aluminum paint that has aluminum flecks in it, and then come back and paint black over that. That just seemed like more effort than it was worth. I already mentioned the roof cap. Just add a little aluminum roof cap on there to keep water from getting in. A lot of people complain about condensation in the solar kiln on the collector in the morning. We don't, and so using treated wood on that front edge can be important. We did not have that problem because the students that bought our corrugated connection material got rounded connection instead of the geometric shape that the Tough Techs actually came in. And so there's a little gap in there down on the bottom, and any condensation we have typically rolls out that gap. And you might say, oh my goodness, that's letting the heat out, but it's pretty insignificant. We're still able to dry red oak in about 30 to 35 days in the summertime. And so I don't consider it a big issue. I thought I would come back in and put foam in there, expanding foam in there, and just never found the need to do that. So a lot of people ask about the plenum, the baffle, I should say, and the plenum space. So the baffle, we just use just a blue tarp, right? Simple blue tarp. Why? I can hang it up here on my fan wall. I can tuck it under my plywood sheet that's on top of the lumber. I've always put a sheet of plywood painted black on there as an absorbent, and also to keep the sunlight from hitting the lumber directly. I don't want the sun to hit the lumber surface directly. And so I just take that plastic, I tuck it under there, and we're good to go. The reason you want to have something there is you want that airflow to move around and go through the lumber, through those little sticker spaces, rather than through this big opening here. And so ideally, if I use shorter lumber in the kiln, I'll also put one on the ends. But if I've got the full 12-foot length of lumber in there, I don't usually worry about the little bit of space on the ends here. The nice advantage of the plastic is if when you want to get it up out of the way, or if you change the height of the pile, very easy to do that with a piece of plastic versus say a sheet of plywood that's on hinges. This space here between the wall and the lumber, there's one on the front and one on the back. That in a big commercial dry kiln, we would call that the plenum space. And the plenum space is necessary to create a more uniform airflow through the top and the bottom of the pile. And the closer you get this to the wall, the more problems you have. And there's actually kind of a rule of thumb formula for that. But it's very important to have some space in here to have that airflow move around and pass through at a more uniform rate through the pile of lumber. Now, this design is one we did for South America. You'll notice the roof isn't quite as steep, and that required, the fact that it wasn't as steep required us to make it a wider building. And that's why you see a wider plenum than what we have in this structure. The solar kilns come a long way. This is actually the very first original solar kiln built by Gene and Fred Lamb This one was loaded on the side and actually on the front. So it was hinged on the front. The top opened up, the bottom opened up, and you could load it. You could see the fans were in the front rather than up on the top. I don't lose sleep about where those fans are located. You can argue very technically about the exact location they should be at. I prefer to have them up here and blowing the warm air down and through the lumber. But the efficiency difference is pretty minor. As long you need to have fans to move that air to get the warm air to the lumber and to carry away the humidity off the surface of that lumber. Very important. Other things you want to do, designs to be completely solar. Hey, I'm off the grid. What do I want to do? There's really two ways to do that. One is to use a solar panel and charge batteries for the fans, which is not a bad way to do things. I've seen people take, for some reason, Volvo cars have a fan, engine cooling fan that seems to be the right voltage, and it's pretty common for folks to grab those and get some batteries and tie those solar panels into those batteries and do it that way. But if you're looking at buying, and these are some pretty old numbers, if you're looking at buying solar panels and motors and fans to run off a battery, you're looking in today's values probably over about $1,000 per fan. So that's $3,000 for 3 fans. I didn't have $3,000 in the whole solar kiln at the time. So this is obviously the most expensive way to go. And there's really no advantage to this method. Although people do it, they'll use it. This is an example of a group from Asheville that came up, took the solar kiln class and built this and did it that way, right? So they've got their solar panels on here, the batteries are somewhere around there, and they power these 2 small fans in here. Very common way to do this without the battery is just solar powered gable vents, and you can get these online now. They're a little bit more than $179 a fan, but they're still very reasonable, around $200 per fan. Very reasonable to do. Little solar panel up front, put the fans in the back, and you might think, well, they're not running if the sun's not up. Well, that's okay, because in the operation of this solar kiln, we don't actually run the fans at night. Okay. One of the things we do is we shut the vents if they happen to be open. We shut them. We let the fans turn off, and we don't run them during night. We let the humidity come back up in that solar kiln. And the reason we do that is it conditions the lumber a little bit each night. And you can argue how effective that is, but if you think about air dried lumber, there's typically less stress in air dried lumber than there is in kiln dried lumber that hasn't been conditioned. Why is that? Every night, if you're air drying lumber, the humidity comes up, the drying process stops, and you actually put a little moisture back in the surface. The next day you begin the drying process, you evaporate that water off, you dry it some more, and then the next night the same thing happens. And so you tend to less stress built up in the woods than if you're drying 24/7. If you're drying 24/7, you're always losing moisture, you're building up stress in that piece. Now, if you have a way to relieve those stresses, that's not a problem. But in the solar kiln, how do we relieve those stresses if we create them? You don't have a really good way to do that. So the goal is try to get some conditioning going on each night, some stress relief each night, so that you don't build up too much stress to the drying process. And so that's why we don't run the fans. That's why we don't use heat sinks in the solar kiln either, right? If you could put a block in there, a concrete floor that holds the energy in there, we don't want to do that, because then it's going to keep it hot and keep it drying all night, and you will not get that stress relief or that conditioning. You can build any design you want at any level you want. So when I was in Tennessee, someone said, hey, this is how I'm going to build my solar kiln. They had less than $100 in the kiln. It was all plastic. And they said, hey, when that plastic falls apart, I can just get some more plastic from Lowe's and Home Depot and just keep on going, right? You can adapt it to have a bigger solar collector face, because you're going to be drying a different species and you want to violate that 10-to-1 board foot ratio. You can build a portable one, just make it a little bit smaller. And if any of you are interested, I did an article for Sawmill and Woodlot magazine with Gene Wengert on one of these that would fit on a trailer. And I'd be happy to, if you just shoot me an email, I'd be happy to send that design to you if you want. We actually had someone come into a solar class once that said he wanted to build a portable one, because he was drying on someone else's property, and you might have to move it if they decide they didn't want them there anymore. So the design's available for that. They're a little bit smaller, not quite as much board footage, but works just fine. Here's the original Solar Kiln. This is the more modern advancement. I like to show this picture because you can get an idea how long it's been around by the pickup truck. But we've got it plugged into the grid. It's always been plugged into the grid so that we can run the fans. You can see here that they've actually used, this is a fiberglass. This was clear fiberglass, which is pretty common in some of the South American countries. Not as good a transmission rate, but it still works. And so one of the things about the Solar Kiln, it's a very simple design, very straightforward. We tend to use a little bit of time to our advantage. In other words, to get to the final moisture content. And so if there's any inefficiencies, we consider that, eventually you will get there if time is on your side. Okay, that's both an advantage and a disadvantage for a lumber drying operation. This was Dwayne Griffith came to one of our Solar Kiln classes and built one of these. I show this example because people always ask, can I just build this out of the wood that I have? You sure can. You don't have to go out and spend a lot of money on plywood. This is a board and batten structure. It works just fine. We had another gentleman that came in 2010 that was wanted to dry southern yellow pine. That's all he wanted to dry. Was going to make flooring out of it for his new house. And so I said, go ahead and violate that 10-to-1 ratio and use as high fan speed as you want, because obviously southern pine dries at a significantly faster rate than does oak. And so he built a very large Solar Kiln, more collector than violated the 10-to-1 board foot ratio, put a lot more fans in there. Was very happy with the final product, but I will point this out. He did mention that he had some stain issues and was concerned about that. And those stain issues, I talked to him about that, where he thought that was occurring. And so he air dried his lumber and then finished it off in the dry kiln. And he sent me this picture. This is the air drying of his lumber before he put it into the kiln. Now notice on that air drying lumber how close all this is, and that there's something back here. And so there isn't an opportunity for a lot of airflow in here. And remember, we were talking thousands of pounds of water that we have to evaporate. And so if you think about how much water we have to lose and how much is being evaporated, you can see that you can create a microclimate of very high relative humidity around piles of air dried lumber. So if you're trying to avoid stain, the goal would be to have this in a very open space, have the airflow getting to it as much as possible. Don't block off where that air can go. Let it pass through the lumber and get it out of there to get a good drying rate to prevent stains from occurring. This is an example of a gentleman that lived in Colorado and sent me an example of his kiln. He was always fun to correspond to because he was his email was the toilet man. I guess he was in the portable bathroom business, but he built one of these in Colorado and used the gable solar vents, had great success with the kiln out there. I like to use that as an example. And so there's all kinds of things you can do, right, to modify the design and do what you want. Let's get into operation. So what do you have to do with one of these things? If I built one and I want to operate it, how detailed do I need to be? So a couple of things. Let's go over a couple of things you don't want to do. Remember the plenum space I mentioned. You don't want to do this. You don't want to pile that thing so full of lumber that you don't get good airflow. You'll see sometimes in the forums, people will talk about the lumber gets down to a certain moisture content or they don't have good uniform drying conditions. This is sometimes why, right? You don't want to choke off that plenum space. Make sure you got a plenum space in the front and the back. Try to keep that 10-to-1 board foot ratio, very important as well. Do I really need to monitor the drying process? Well, how much control do you need, right? We talked about the kiln is designed to provide a certain amount of heat. The relative humidity is going to change as the drying conditions change. So is the temperature. So there's no place you walk out there and turn a dial and change the heat. There's nowhere you walk out there and change a dial to change the relative humidity, right? So where you want to start monitoring things is when if you ever want to violate that 10-to-1 board foot ratio. So let's say I've got I've got a dry kiln built. I usually dry hardwoods in there. I decide I'm going to dry some white pine in there. Well, you could put half as much lumber in there and thus double the collection to board foot ratio to get a different drying rate. Well, you might want to put something in there to measure the temperature and relative humidity to make sure that you're within some relative good parameters. If you're going to modify what's going on in there, you probably need more information. If you're not going to modify what's going on in there, really the only two things I think you need, or that I would recommend, is a humidistat to control the electricity going to the kiln and a timer. And so the humidistat is used to turn the fans off on a rainy day, because there's no point in running the fans on a rainy day because the relative humidity is going to be very high and you can ultimately be re-wetting the lumber. So go ahead and shut those fans off and call it a lost day for drying. It's Mother Nature, right? The other thing you want is a timer. And a timer you want so that the fans come on in the morning, maybe about an hour or two after sunup. As the air begins to heat up, you start wanting to move that air, and then you can shut them off about an hour or two after sunset, okay? So the goal is after the sun goes down and things start cooling off, I want to stop the airflow, let the humidity come up inside that kiln so you can get some stress relief. So, and the kiln we have here that I operate right now, the only thing I have on it is a timer. Theoretically, I'll go out and unplug the kiln when it's raining, when I'm drying lumber in there, but I definitely have a timer on there. You know, this is the relative humidity and the time of the day. The point is relative humidity changes throughout the day, and it's going to be the highest in the morning, in the early morning, and it's going to be the lowest midday, right? After afternoon, probably around 3, 4 o'clock in the afternoon when the temperature is the highest. And so you're going to get these changes throughout the day. And the goal is to let that humidity come up at night, let the stresses relieve in the lumber so that you've got a good product when you're done. So what do I mean by stresses? So this is a piece of wood that's cut off. It's about a 1-inch thick piece. Thick would be this direction. And it's the thickness of the lumber. And I cut that out of the board, at least 24 inches from the end. I take it to a bandsaw and I cut out the center. So when you cut this piece as a square or rectangle out of the board, it's not going to do anything. But if I cut the center out and there are stresses in there, they're going to demonstrate what they are, because it's no longer going to be balanced. The stresses are not going to be balanced. So you typically, at the end of the drying process, you'll see the stresses will cause it to pinch in. Why is that? Because the outside is in compression, the inside is in tension. So the inside's pulling it in and the outside's pushing it in. And so they come together. And this would be an example of what's called case hardening. Now, this is a result of transverse drying stresses that occur in the drying process. Ideally, when you cut those prongs, you want it to look like this. Why do you care? Why do I care if there's stresses in there? Well, if you're going to make something out of this lumber, remanufacture this lumber into parts and pieces, you don't want it to have these stresses in it when you run it through a table saw or run it through a molder or a planer. If you relieve those stresses unequally, then they're going to cause problems. The piece of wood is going to move as soon as it comes out of the machine. So a stress-related issue, the movement occurs as soon as you machine it. A moisture-related issue, i.e. maybe you didn't have the right moisture content and it dries out after you cut the piece. A moisture-related issue is going to happen over time. So after a cut, you're going to cut that piece and 3 or 4 days later it's warped. That's a moisture content issue. If I run this thing through a planer or a shaper, and it warps the minute it comes out of the machine, that is a drying stress issue. Now, there's all kinds of level of stresses, right? I know this is a little blurry, but you get the idea that over here is a perfect stress-free piece. This has a little bit of stress in it. This one has a lot of stress in it. Probably your customer is never going to complain if you've got just a hair stress in there. If you're making really long moldings, really deep profiles, this might be a problem. These two samples on the left, if you've got that amount of stress at the end of the solar drying process, you definitely have a lot of stress in that piece, and that customer is going to complain because they're going to notice it when they go to use their wood. So the goal is not to have these stresses form in the drying process. So example of solar kiln operation. I like this. This was from a little woodworking magazine where they kind of copied our idea and scaled it down. And the guy says, you know, I go play golf after I get it loaded up. So literally, I mean, this is what you can do. You can load the kiln up, maintain that 10-to-1 board foot ratio, 10 board feet for every 1 square foot of collector, load it up, walk away, set the timer in the thermostat so that the fans come on when, an hour or two after the sun comes up. They go off in the evening. Use I say thermostat, that should say humidistat. Have the humidistat turn it off if it's pouring rain, right? And just let it go until you think it's ready, and then go out there in the evening and close the vents if they happen to be open, and shut off the fans. Come back in 30 days with a moisture meter and see what you got. It's a pretty simple operation, right? If you're drying a really high moisture content wood and it's stain prone, I'm going to leave the vents open for the first week to 2 weeks. I have dried red oak in our solar kiln, never opening the vents. And people say, how is that possible? Well, one, we built it, right, as woodworkers. And so it's obviously not the tightest 100% efficient. There is some airflow in there, air movement in there. But basically, most of that humidity escapes through the structure itself, through the cracks around the vents that we're trying to keep closed. And the humidity will drop significantly as the temperature rises. And so even with my vents theoretically closed from the beginning to the end with green lumber, I can dry red oak in about 35 days in the summertime. Now, some folks find that a little disconcerting. So if you really want, you can open the vents for that first week. But after the first week or so, they really don't need to be open, because you're more interested in getting the temperature high enough in there as the drying process continues. And leaving them open creates more of a fan shed situation than a kiln situation. So believe it or not, you can close those things up after the first week or two, and it'll dry just fine. If you really want to get into the details, you can measure the moisture content as the wood dries every day using sample boards. You can check the temperature and relative humidity as the day goes on, and you can try to watch this stuff. Because you could theoretically lower the temperature. How would you do that? Well, you could open the vents and let some of the heat out. Another thing you could do is I could cover part of this collector up with a tarp, right? I could pull a tarp over just a quarter of it, and then pull some ropes forward and tie it down there. And so I could theoretically try to control the temperature that way. I don't recommend it, but you could do it if you wanted to dry something different in there and you wanted to lower the temperatures for a period of time. So you could, get more technical about how to operate it. My suggestion is have a timer on there. If you've got the vents open, close them up in the evening, open them up in the morning, and let that thing just sit for 30 days, and then come back and check it and check the moisture content of your wood to see where it's at and is it done, right? Stain prone species, I mentioned stain prone species. Those are species typically that the majority of is sapwood. The only really difference here is that I'm absolutely going to open the vents during the day and the first 2 weeks, week or two, to make sure I don't stain that material. And I'm okay with the heat loss, because my concern here is more degrade through stain. A couple of disadvantages of the solar kiln. You can probably already guess what most of them are, but two things you're definitely not going to do in a solar kiln is set the pitch and pine. It's just not going to happen. Or use it to sterilize wood, i.e. kill wood boring beetles in there. In order to set the pitch and pine, you've got to be way up in temperature, way up in regards to what you can get with the solar kiln. You want to be about 180, 190 degrees in the wood for at least 12 hours. Now, the solar kiln at best is going to be about 50 degrees above the ambient conditions. So if it's 100 degrees outside, the hottest part of the day, with it loaded with lumber, you're probably not going to get above 150 degrees Fahrenheit. And then you might say, well, if I only need 132 to kill insects, isn't 150 more than 132? The answer is yes, but the center of that wood is never going to get to 150, because that's at the peak point of the day when the temperature is the highest. And that heat has to transfer through the wood to the center. So the center of the wood's never going to get to 150. By the time the wood's starting to heat up and get nice and warm, the sun's going to go down. And so it just doesn't get the temperature high enough, long enough to kill insects. So that's two of the main disadvantages of the solar kiln. So my suggestion, and folks do this, if you want to set the pitch and pine, you dry that thing in a solar kiln, and then you have a heat box, an insulated box. You put that lumber in, and you crank the heat to it using electricity or a gas heat or whatever you want, and in that insulated box. The same thing for sterilizing wood. Same thing. Use a heated insulated box. Other things that the solar kiln does not do well. Everyone seems to be in the slabs this decade, right? You get above 8/4, or I should say 2-inch thick in size, and the solar kiln is really not the best piece of technology. Why is that? Well, remember this, the solar kiln, the collector to board foot ratio, and the fact you only get 1,000 BTUs out of a square foot of collector. You need more heat. You need more BTUs at the end of the drying cycle for thick stock than you do for thinner stock. Yes. Can you hear me now?
Yes.
All right. So thick stock needs more heat towards the end of the drying cycle, because you got to get that water to move from the center of the piece to the surface. And so with thick stock, you want real slow drying at the beginning of the drying stages. And then at the end, you need some heat, and probably around 150 degrees to 160 degrees towards the end of the drying cycle. And so if you want to solar dry thick stock wide pieces, it's not something I would recommend. You'll be in there forever. Could you eventually get there? Sure, you could. If time is on your side, eventually that thick stock is going to reach the EMC of the kiln, but it's going to be probably a year in the making. It's going to take a very long time. So if you're trying to do 3-inch thick pieces, wide slabs, my suggestion is to move to dehumidification technology. It's going to be significantly better for you. All right, what other limitations do we have? One of the other big limitations of a solar kiln is, if I said it before, and I'll use my perfect English here, if the sun ain't shining, the lumber ain't drying. And so if it's a cloudy, rainy day, you're just not drying. If it's really cold and you're only getting 50 degrees, if it's 0 degrees outside and you're 50 degrees above ambient, well, that's still not that warm for drying wood. So you're going to have slower drying times in the late fall and early spring than you do in the summer. And in the wintertime, the idea that you're going to finish a charge in the winter is just not going to happen, right? You're not going to have enough heat to get the relative humidity down to the EMC that you need to finish the lumber. Can you dry lumber in the winter? You sure can. You're just not going to get it to the low moisture content that you want until spring, until the sun's out there longer and you're able to drop that relative humidity long enough to get it down there. So those are some pretty big disadvantages over the solar kiln if you're in business, right? If you've got customers that want wood at certain times and you've promised it and got to get it to them, the solar kiln can be a big disadvantage for you. Now, one way to overcome that is to build an inventory for the wintertime, which kind of painful in regard to cash flow. And another thing you can do for the summer, spring, and fall is to have multiple kilns. So you've got multiple kilns at different stages in the drying process to increase your production that way. A lot of times folks will start with solar drying and decide that they need a higher production rate. And so moving to something like what I have pictured here, which is a indirect fired or direct fired kiln, is a way to do that. So basically you got a heat transfer mechanism in here, you're burning gas or whatever you want, wood, you could use hot water, but you're controlling that process, the temperature and the airflow pretty strongly with a different technology, right? Same with the dehumidification kiln. So I'm pulling moisture out of the air by condensing it on some coils. I'm controlling the heat. I can get a uniform and consistent cycle time regardless of the time of year using these other technologies. And so as you move into higher production rates, meeting the demands of your customer, or if you need thicker stock dried, these other technologies, they're more complex.
Think about this.
They're not just plug and play.
A roof over.
they are you're going to have to know how to use the schedule, and you're going to have to know where to get that schedule and how to control the temperature and the relative humidity. So the other technologies have advantages, but the solar kiln is pretty straightforward and easy to do. It is something you could do off the grid. So with that, I've thrown a whole lot of stuff at you. And how did I do time wise? And just a little bit over an hour. And so I'm going to stop my screen share and I'll be happy to answer some of your questions.
Dr. Bond, I wanted to ask if anyone ever uses a dehumidifier, just a simple household dehumidifier to speed up the process.
Yes. So if you're going to go that route, a couple of questions for you, or a couple of suggestions. One, I don't recommend putting a dehumidifier in the solar kiln. My recommendation would be, if you're going to go with a dehumidification, go ahead and build a DH kiln. And you can build a DH kiln with a home humidifier. The disadvantage of that is if you use species like oak, the tannic acid in that oak will eventually completely destroy the fins in there and the unit itself. So you'll probably only get a year or two out of that unit. You're better off buying a stainless steel unit from somebody like Nile or Wood-Mizer or what's the other one? There's a couple commercial companies that produce them for those particular purposes, and you'd be better off with one of those. But you can. I mean, there's articles. I wrote an article with some guys in Wisconsin how to build one out with a DH unit and do it yourself. There's an article out of the Forest Service out of West Virginia, the lab at Princeton on building one out of wood and plywood and a home DH unit. You can do it. It'll work. It's just you are gonna chew that unit up after a period of time. Good question.
So why wouldn't you put a dehumidifier inside a solar kiln? Is it because you would lose too much heat through the tough text or whatever you use on the top?
Yeah, why bother? If I've got a DH unit in there and I'm going to control the process with the DH unit, why bother with the sun? Because now, and the other thing that you've done is you're beginning to change the design. So the design is set up so that the temperature and relative humidity are going to change exactly how you want them to through the drying process without you knowing anything about it, right? You can put the wood in there and walk away and come back and it's done. You put a DH unit in there, now you're starting to change the relative humidity. So now where do you need to be with that relative humidity at what stage in the drying process so that you don't dry too fast? Well, you can get that information, right? There's drying schedules. You can get the dry kiln operator's handbook. You can download the schedules from the Forest Products Lab. I mean, there's Nile will probably give you some schedules if you buy their unit. But now you're controlling the relative humidity. You're operating it in a way that now you need to measure what's happening in that system, and you need to know what to change and when to change it. And so, in my opinion, if you're going to go that route, you might as well go that route. Does that make sense?
Yeah, it does. I was just thinking of the off seasons. I mean, I'm in an area where I'm going to get probably about 6 months out of the year that's going to be good for a solar kiln.
Yeah.
I'm going to get, 3 months that are kind of and then I'm going to get the rest of it that are crap. So, could I dual purpose basically the framework? Is what I was
the other problem is you do lose a lot of heat through the glazing material. And so when, even if you're going to finish off in the wintertime, it's going to be so cold in there because of the heat loss.
Yeah.
That my recommendation would be you have a little DH unit over there and you pull that wood out of the solar kiln, stick it in that DH unit in the wintertime and go ahead and load it up and with the next load. And so you're just finishing it off with the DH unit.
Right.
If you've got the solar kiln. Now that assumes that you have a way to move the lumber as a pack, right? Because you're not going to do that if you're moving board by board by board. So I'm assuming that you've got a farm tractor if you're going to do that, or some type of rolling system to do it for you. But are you the gentleman in UP?
No, I'm actually in Ontario.
You're in Ontario. So believe it or not, people in BC, British Columbia, built these things. I don't know why, but You know, some of those northern climates, they'll build them and use them through the summer without any problems. But yeah, in the wintertime, you're just not, you know, you get down to those minus below zero temperatures, just nothing's going on. It's frozen.
Yeah.
Yep.
Thanks.
Yep.
On that topic, wouldn't you be able to increase your production if you used the dehumidifier and just had it run at night, so that you would be able to start up earlier in the morning?
No, and that gets into stress relief. Remember, the reason I'm not drying at night is not because I can't, because I could theoretically put block in there and you know, heat sinks in there to keep the heat up. I don't want to do that because I want the humidity to come up and I want to stop that drying process and relieve some of those stresses. And that is why I don't want to run 24/7. So if you dry 24/7 in a DH unit, you have to worry about stresses even more than you do in a solar kiln. And so having some way to relieve those stresses at the end becomes very important.
Well, I've got a related question for you then.
Okay.
I've heard some people when they're seasoning firewood, they say that if you wet it, that it actually cures faster. And I wonder if the same thing would be true on the lumber. If you sprayed it on the outside, does that help wick the moisture out of the heart of the wood or no?
No, physics does not suggest that is a good idea.
Okay.
Yeah. Now, what can happen sometimes in a drying process, which I wouldn't expect any of you to experience, but in a commercial kiln, sometimes they'll dry hard and fast enough that wicking in a species like hickory is a classic one that's very dense. And so you can actually dry fast enough in hickory where the drying process will begin to stop. And that's because you've kind of broken that wicking process. And so you kind of have to wait for the moisture to dissipate. But, you know, above fiber saturation point, I wouldn't expect that to be much of an advantage at all. So no, that would not be something I would do. And honestly, in drying lumber, I never, ever, ever want to re-wet it, ever. Because you think about the outside of that lumber is going to, the very, very fibers closest to the surface are going to be almost at EMC very quickly. That means they're below fiber saturation point and they're starting to shrink. If you throw water on there, they're going to expand, right? And so the more expansion and contraction you have, the more opportunity you have to create surface checks and end splits. And so personally, I never want wood to be re-wet. Matter of fact, if I'm air drying, I've got it covered. I've got and then when I say covered, I don't mean the whole thing. I just mean the top. I'm keeping the sun and the rain off of it so that it's not getting re-wetted. I never want my dry lumber or lumber in the drying process to get re-wetted. But it's a good question. It's a good question.
Do you ever paint the ends?
Okay, so that's another great question, right? So why would you paint the ends? So especially in thick stock, painting the ends with a paraffin wax and what we call an end coating is a great thing to do. The reason you do that is to prevent the end grain from drying too fast. So end grain dries 10 to 15 times faster than the transverse surfaces. Well, let me put that in plain English. So the end of the boards dry 10 to 15 times faster than the top and bottom surface and the edges. And so that's what causes end splits. And you'll notice that in thicker stock, end splits happen even in species that typically don't split. And that's because it's just a thicker piece. You get more stress buildup. And so absolutely. And if I was a small dry kiln operator or small lumber producer, I would absolutely be using an end sealer. Now, paint does not do a very effective job. It just doesn't. You're better off buying a commercial product for lumber. UC Coatings is a company that will sell you a 5-gallon bucket of stuff. What are some other ones? UC Coatings and a product called Anchor Seal. Any quick online search will tell you some of the other competitors, but it's a great product. You know, if I had my own portable sawmill and was in the business, I'd be end coating my logs so that lumber was already end coated when it came from the sawmill, so I wouldn't have to do it again. But that's a great question. Yeah, I would be end coating any oak any of my denser species or any thick stock, anything 2 inches and over, I'd be end coating everything with a end sealer, specifically for lumber. What else you got? Don't tell me I answered all your questions.
You do an incredibly good job, very thorough. So thank you.
Oh, you're welcome. I hope I didn't throw too much out too fast. I always worry about that.
Doc, I do have a quick question. This is Randall. I'm pretty close to you down in Paint Lick. I may have missed it earlier, but do you you recommend a like air dry it down to about 20% before you stick it in there, or are you putting just fresh cut lumber in your kiln?
You know, I've pretty much always done green off the saw for what we've got here. And there's nothing special about that. It's just, you know, I'm usually trying to push it to see what it'll do, rather than, you know, I'm not in the commercial drying business. If I was trying to dry lumber and sell it to people, I would absolutely air dry first. Why? Not because it's necessarily better, but I can get more throughput in that solar kiln. Right? If it takes me 35 days to dry red oak from green to dry, I can do it probably in 15 if I had it air dried. I could double my capacity. So I'm not doing it so much out of concern for what's going to happen in the kiln. You know, that 10-to-1 ratio will, you won't check the lumber in there with that if you maintain that ratio. I would do it to speed up my, you know, increase my throughput.
Okay, makes sense. Appreciate it. I did build your kiln a couple of years ago, and I've had quite a few loads go through it, some slabs and some dimensional lumber too. So, and it works very efficiently, and very, very happy with it. So thank you.
Yeah, very good. Someone asked here, unfortunately, we had a poor connection. Any chance this was recorded? Bill, I think you're recording this, aren't you?
Yes, that's correct. It's being recorded, and we will post it on our YouTube channel tomorrow, and I'll post that in the Facebook portable sawmill site, so y'all can find that link in there.
I have a question.
Yeah, go for it.
I have a dehumidification kiln based on the design from Princeton, West Virginia. Been drying for about 10 years. With the solar kiln, do you recommend that they have samples and calculate the moisture content at the end of the cycle, or do you recommend that they use a moisture meter?
Well, unless you're doing something new, like if you violate that 10-to-1 board foot ratio because you want to dry faster, or you build a solar kiln with a bigger collector, I would use sample boards to see what my moisture loss per day is on the front end to make sure it's not too fast. But if you stick with that 10-to-1 board foot ratio, I'm going to come in with a meter at the end and check to see what that moisture content is, because there's nothing I could do really. There's nothing you need to do in that process other than turn the fans off at night and close the vents up. There's nothing you really need to do with that information. Now with the DH kiln, you've got a schedule to follow, right? And so you're changing that humidity based on what the moisture content of the lumber is. So you need that sample. So I'd say unless you're going to do something different with the solar kiln, I wouldn't bother. No. Now, one of the things I did not mention is that when you check the moisture content at the end of the drying process, I want you to check not just, you know, put the pins in 1/4 of the thickness. I also want you to have a probe that will drive those pins all the way to the center. Because one of the things that's very common is to think your lumber's dry, but have a wet core. And so I want you to make sure that there's a very small gradient, if any gradient, between the outside of that piece and the center. So I want you to have the kind you can drive in there. And if you can't, then I would cut an oven test at the end and do what I call a shell and core test to make sure. That's pretty vital if you're selling lumber, to know what the average is, but also the difference between the shell and the core.
I have a question.
Yes.
Oh, so we milled some slabs at 2.5 inches. Can we still put that in solar film?
I heard the first part, but not the last part. Something about you milled it to 2.5 inches.
So we milled slabs at 2.5 inches, hoping to put it in the solar kiln, but you're saying not to use it at 2 inches. Not to
Yeah,
use it
so-
less than 2 inches.
Yeah, so it's not that you can't, right? It's not that you can't. It's what happens is as you get a slab that's really wide and really thick, the drying time, because of the low temperature, becomes very long. And so if you're doing this for business purposes and you're interested in cash flow, you want to be able to dry it faster. So you will eventually be able to dry it in the solar kiln. Just as a business proposition, it's going to take you a while to get there. And so one of the things that I would suggest is on a slab like that would be to air dry it really well, probably 9 months. And then I put it in that solar kiln below 30% moisture content, and I would violate that 10-to-1 board foot ratio. I would go with probably double. Make sure you have it end coated.
Okay, what's the largest you would go?
What's that?
The widest slab, what is the widest slab you would put in there?
It's the same thing. I mean, the wider it is, the longer it's going to take. Yeah. And
Okay,
I would not want to have a 10-to-1 board foot ratio at the end of the drying process. I'd go ahead and violate that, the drier that wood is, so that you get more heat in there. And then I'd make absolutely sure to check the core with a pin meter on the back side before you're convinced it's done. Somebody had their hand raised.
Dr.
Pete,
Bonner,
Go ahead. Someone asked a question here. Can you add additional heat source to your solar kiln? Yes, you could. The problem here is two things. One, when would you add that heat? No, there's three things. One, when would you add the heat? How would you get it uniform across the length of the kiln? And then three, when would you do it? So maybe I already said that. So the other problem is the heat loss through the collector. So you're going to have significant heat loss through the collector if you do that. You're going to have a hard time getting uniform heat distribution throughout the length of the kiln. And if you did do it, I would say do it at the very end, right? Because you want to avoid any potential defects, right? And so controlling a schedule, what I would call a drying schedule, controlling the temperature and relative humidity off a schedule is really important on the front end. Once you drop below 20% moisture content average, it becomes less important. So I would say when you're down around 15 to 12%, that's where I would put the auxiliary heat in. I wouldn't do it on the front end. But yes, you could do it to speed up the process, but think about how you're going to do it uniformly, how much heat you're going to lose through the top of the glazing, and then three, when are you going to do it? But yes, you can do it. You can. Be careful though, because another thing that can happen is if you drop the relative humidity really low, you can actually end up with a really dry outside and a wet inside still. So the outside could be less than 5%, whereas the inside could be up around 15%. So just be very careful of that as well. But yes, you can do that. That would be one where I'd want to monitor the relative humidity to make sure it's not dropping below 20% while you're doing it. But a good question.
You mentioned about conditioning that happens essentially nightly. Because that conditioning cycle happens generally on a nightly basis, does that mean there's no need for a conditioning cycle at the end of the process?
Theoretically, the answer to that question is nope, you don't have to do anything. So stress buildup, typically the harder you push through the process, the more stress you have at the end. And so a lot of drying processes, like, DH drying, they'll tend not to push it as hard as you could to try and keep the stress limited at the end. So the harder you push in general, the more stress you have to relieve at the end. Generally speaking, the solar kiln is gentle enough because of that conditioning every night that you really don't need to, there should not be too much stress in those pieces. I'm always going to cut a stress test because I didn't say always, right? I'm going to cut to check to see if it does happen because it's possible you might have stresses in there. And then the question is, what do I do about it? And I hate to have this recorded and say it out loud, but you can do things like throw buckets of water on the floor to raise the relative humidity. You could buy a steamer and put steam in there. It's not super effective, but it's better than nothing. And so you would raise that relative humidity for a period of time and then cut another stress test, make sure your moisture content's correct, and then pull the load.
Okay.
But the goal is to keep it as low as possible. Having those prongs pull in a little bit isn't too bad. Like drawer fronts and short pieces, you're never going to notice if you plane the piece equally on top and bottom if you have just a little bit of stress. But if you have a lot of stress in there, it becomes very difficult to make good pieces out of it. And most of the time in the solar process, you're just not pushing it hard and fast enough to have that issue. But I'm not going to say never. I have absolutely seen stress in solar kiln dried lumber. I've seen stress in air dried lumber. It's possible to do. So I'm always going to cut that test to make sure that I don't have significant stresses at the end of the process.
Great.
Getting them out is tricky in the solar kiln. What else?
I have a question, Dr. Bond.
Yes.
I started carving gun stock several years ago. That's what got me into buying a sawmill and drying my own lumber. And I make my gun stocks out of laminated walnut, maple, and cherry. I first started out cutting all 1-inch boards and resawing them. And then I had a customer that wanted an order quicker than I had time to process the lumber because I air dried to below 20% first.
Okay.
And then I used a solar kiln to get them down. And I did it on a very gentle schedule. Wasn't in any hurry whatsoever because I didn't need that much production. I wasn't trying to, shoot out a lot of lumber. But when I cut those inner strips, instead of resawing 1-inch boards, I went and flat sawed straight through some small logs, took those slabs, cut either a 1/2 inch or a 1/4 inch, cut them to gun stock shapes and planed them real quick. But I planed them green the day I cut them. The reason I did was to get that fuzz off of them so it'd slow the drying. And then those short 3-foot pieces that were 7 inches on one end and 3 inches on the other, I stacked vertically. They didn't warp. No other way have I done that they haven't warped like a pretzel. But if I stacked them vertically and I put them in my attic in a 2-story farmhouse with a heat pump running, and they went from green cut to 6% moisture in 2 weeks because they were so thin.
I can believe that. Yes.
Is there any better way to do that?
When you say better way, I'd be willing to bet that the grain in those pieces was very straight.
It was, because when I put my logs on the mill, I center the pith.
Yep.
And that's the only way to make perfect gun stock blanks is to have that straight grain in there in the inner pieces.
Yes, and I imagine that had more to do with why it didn't warp on you than anything else.
Okay, that was my biggest question, is I couldn't get past the point that it doesn't warp.
Yeah, that would be the only thing that would explain it to me, because I even a thin piece, if you've got spiral grain in there or tension wood in there, even a thin piece is going to move significantly.
But all of them cut that way. The bulk of this stuff then is actually quarter sawn.
Now, quarter sawn is more dimensionally stable to begin with.
Right. But the center of that log, all of that log going down through there, 1/2 inch and 1/4 inch thick, is basically quarter sawn.
Yeah, and so that's why it won't cup on you. Yeah, if it's
But
quarter
if I
sawn.
stack them horizontally and sticker them, they do.
Really?
Yeah, I have no explanation for it.
Me either.
But if I stack them vertically, they dry perfectly flat.
That is bizarre. I don't have an answer for you.
I just got
My-
lucky.
My expectation would be to have more to do with how close you get to the pith and
Mhm.
into the juvenile wood zone versus how far away you are from the juvenile wood zone.
Right. I don't use the outer portions because of that juvenile wood. I don't use the center pith whatsoever. I make table legs out of the center of those logs.
Yeah, that would be my expectation that how you laid it would have no impact. It could be the speed of drying, but again, if you're putting them in the same place, I can't see why vertical orientation would make a bit of difference.
It's amazing that they go from fresh cut to 6% in 2 weeks.
Yeah, yeah, it is. It's that nice thin. You can push walnut. What did you say you were cutting walnut?
Walnut, maple, and cherry.
Yeah, you can dry walnut pretty fast.
Yeah. And the wood that I was able to dry the quickest, though, is Texas mesquite.
Oof.
I've had 4 logs brought all the way from Texas to make gun stocks with.
That's an interesting wood to dry, to say the least. Yeah. Yeah, I can't explain that. Why it would be any fat? Why it would stay any straighter? I can't see a reason for that. You're on to
So
something.
thank you. And I really appreciate this seminar. Most of it I already knew because I've been doing this a long time. I've got one of the 2,000 board foot models built from the modified plans. And I'm the administrator on the sawmill forum.
Okay. Very good.
All right.
I just had a quick question. I was wondering, being as I just, would be drying for myself in my backyard, so to speak, if I were to build to the plans but not run a full load through the kiln, what would be the solution on that type of situation where, maybe I've just got a backyard tree from a buddy and no more lumber coming in? Would you, say cover part of the collector or just wait and air dry until I get a full load? But then I'd have, sections of that load being at a different moisture content than other parts. What would be the solution in that type of situation?
So it depends. So I'll throw that out there. My favorite answer, right? It depends. So it depends what it is. Just an example. If it's red oak and it's 2 inches thick, I'm not gonna throw it in there because if I violate that 10-to-1 board foot ratio, I'm gonna check the heck out of it. If it's really low density species that's not check prone, like yellow poplar or walnut, something like that, I'm okay violating that 10-to-1 board foot ratio. If I'm not sure and I don't know and I'm uncomfortable doing that, I'm going to air dry whatever it is down to about 20%. And I'm going to throw it in there and not care that I violated that 10-to-1 ratio, because once you're below 30%, you're not going to surface check that lumber. It should be dried and you should not be able to create enough stresses to surface check it. And if you're below 30% and it's 4/4, you really shouldn't have enough heat to honeycomb it. So you're not really going to hurt it by violating that ratio. Once you get down to 20%, violating that 10-to-1 ratio, I'm absolutely fine doing that. No issues there. So I would air dry it until you get down below 30, and then I'd throw it in there.
That's great. Thank you.
Absolutely. You mentioned not to run the fans when there's high humidity. What is the minimum temperature, minimal temp? If it's raining, I'm not running the fans, regardless of what the temperature is. Just if it's 90% humidity, you know, if you're using a humidistat, set it to 90%, and just have it shut it off, and don't worry about the temperature. Good question.
Is there a need to weight the pile or strap the pile down like you see in other implementations, or is it because the solar kiln's a little softer on the implementation in the drying process that you may not need that? What's the thoughts on that?
Well, you know, you run into a problem here. So using pile weights is always a good idea. You know, 50 pounds a square foot at least is a great way to keep your lumber flat. But the problem is when you do that in the solar kiln, you add a heat sink.
Yeah.
Right? So I don't want to do that because it's a heat sink. And then the strap idea, I've seen some pretty crazy looking strap ideas. The problem with straps, in my opinion, is they do a great job of holding get my camera here. They do a great job of holding the edges good, but they don't do anything for the middle. And so their effectiveness is really questionable. Whether you get 50 pounds a square foot across it is really difficult to say. Some of the most clever ones I've seen are where you have a I-beam that goes across and bolts on the side, and you bolt that pressure on there and you continue to add pressure as it dries. But that's the other problem. As it dries and shrinks, it lets up on any of the pressure you put on there. So then you're going out there and doing it again. But it tends to put so much more on the edges than it does across the center. I'm not convinced that it actually does much good for you.
Okay.
But you know, ideally, you're absolutely right. I want weight on there all the way through. I want at least 50 pounds a square foot. But I'm gonna say sacrifice a couple of boards and have a little bit warp so that you don't have the issue with stress at the end.
Thanks.
Regretfully, yeah, another disadvantage of the solar kiln. I think we've worn people down, Phil. I think we're done.
Well, you have a follow-up question in the chat.
What? Sorry, what I mean is if it's 0 outside, I probably wouldn't run the fans, but 5 degrees Celsius would be good. Oh, okay. Yeah, if it's below freezing, there's just not much point. If it's above freezing, then yeah, I'm gonna run the fans. I'm gonna run the fans if it gets above freezing. Absolutely. You're not gonna get great drying, but you're gonna get some. And running those fans is gonna get evaporation. But if you don't have water, then yeah, and on Western Ontario, yeah, you're gonna have very cold days. You're gonna be below 0 quite a bit.
Okay, last call for questions. Any last ones for Dr. Bond? And if not, Dr. Bond, thank you very much for an excellent presentation. And this will be posted tomorrow. And Jeremy, are you here close? Tell us what's coming up next week. I know he had to step away for a second. Okay, yeah, I think Jeremy stepped away. So again, thank you all, and hope everybody has a great evening.
Yeah, thanks, Phil. And if anybody has any questions, just shoot me an email. I'll be happy to keep the discussion going. Have a good evening, everybody.
Great. Thank you.